Okay, in this presentation we are going to look at survival analysis again. So the Super Light company makes light bulbs, okay? So they have developed a new type of light bulb which it recently tested. So 1000 light bulbs were switched on, okay, and observed until they failed or until 500 hours have elapsed. So essentially the entire duration of this experiment is 500 hours. So if they last longer than 500 hours, then we have that type of censoring there, that right censoring. So for each bulb that failed, the duration in hours until failure was noted. Now, so just a little bit of a note about censoring, okay, that will take place during the experiment. Due to an earth tremor after 200 hours, 200 light bulbs shattered and had to be removed from the test before failure. Okay. So we're going to sort of incorporate that in. Well, here are the main set of notes. So 10 light bulbs failed after 50 hours. 20 light bulbs failed after 100 hours. 50 light bulbs failed after 250 hours. 300 light bulbs failed after 400 hours. And 50 light bulbs failed after 450 hours. So it's all pretty much split up into 50-hour periods, essentially. Okay, so calculate the Kaplan Meier estimate of the survival function S of t for the light bulbs of this test, and sketch the curve. Sketch the Kaplan Meier estimate. I call it a curve. It's not really a curve. It's a step function. I have to get out of the habit of that. Also, one more question. Estimate the probability that a bulb will not have failed after the following durations. 300 hours, 400 hours, and 600 hours. If it's not possible to obtain an estimate for any of the durations without additional assumptions, please explain why. So without any additional assumptions, So just actually, I'm going to sort of flag this now. It's related to this one, this last question here, which is 600 hours, because the experiment only lasts 500 hours. So essentially, we can't really tell without making additional assumptions. Okay. So, essentially what we're going to do is, I always find it handy to set up these tables. Now, if you're doing survival analysis, you've probably done a few statistics courses already. But I reckon actually this stuff is handy enough, really. So, what we're going to do here is just talk. It's essentially what I'm going to do is reuse the information that I was given previously. So what we have here is we're starting at a period that starts at 0, time 0, and ends with time 50. So this is the first period. It starts at 0, ends at 50. The second period starts at 50 and ends at 100. Well, actually, 0 to 49 hours and 59 minutes, if you want to be absolutely correct. I'll just try and keep things as simple as possible here. So the first period. So we start off with 100 light bulbs, and nothing really happens. None of them break, but we don't lose any either. So essentially, nothing really happens, okay? So the second period, which starts at 50 hours and goes on until the 100th hour, we have 1,000 light bulbs, and 10 of them break, okay? We don't lose any, okay? So essentially, the event probability for this period, which is 50 to 100 hours, is 0.1, which is, in other words, 10 out of 1,000. So 1 minus, so that's actually what sometimes we might denote that as lambda j, and 1 minus lambda j, okay? And that's essentially the event probability, or the estimate for the event probability. What is our estimate for a light bulb breaking down in that interval between 50 and 100 hours, and what's the probability of it surviving, estimating the probability of it surviving. So it's 0.01 for failure and 0.99 for survival, respectively. Now, what we're going to do here, we'll keep going. The next period, we start off with 990 and we're left with 20. 20 of them break, okay? And so 20 divided by 990, that is 0.0202, okay? Which is 20... It is 2 over 99, or 20 over 990. So that's the probability of breaking down. The probability of survival is 0.9798. 200 hours. So this is actually where the censoring comes in. Between 200 hours and 250 hours, we lost 200 there due to that earth tremor. So we don't lose any, but you just notice that when we start the next period, so this is the period from 200 to 250 hours, starting with 200 and ending at 249, just so this starts at 250 here. So when we start this period at 250 to 400, we've just lost 200 light bulbs in the last period. None of them break, but they got shattered due to that earth tremor. So we're starting off at 770. We lose 50 of them break. We don't lose any more. Okay. So the event probability is 0.0649. The probability of survival in that period is therefore estimated to be 0.9351, and then so on. So essentially, I'll just try and speed it up there. So the next period, 400 hours to 450, okay, and so it is the 720 is what we start off with. We lose about 300 in this period. Sorry, I just had to pause and go back and check that. Yeah, we lose 300 in this period. This is sort of making more sense. The longer we go into it, the more, we're expecting more to break down. We don't lose any, okay, and therefore we have an event probability of 0.4167 and a survival probability of 0.5833, okay. So finally, the last period is 450 onwards, okay. So just watch this here for a second. In this video, I'll go into more detail on it. So we start off at 420. 50 of them break down around the 450th hour, but we have 370 that survive on. Now, these are going to be counted as censored, okay? So we don't really know when they're breakdown, so they just write censored. But they're not that 370 is not really used as part of the calculation. The 50 is 50 divided by 420, that gives us 0.119, okay? That's the breakdown probability, the event probability. So the survival probability is 0.881. Okay, so essentially what we have to do here is collect up all the Kaplan Meier estimates. Now, let's look at this here. So essentially, the Kaplan Meier estimate is the running product of these numbers here, the survival probabilities. So in the first instance, we start off at 0.99. Then it gets updated to, it gets updated to be the multiple of these two, okay? And if you work that out, we have, start off with the 1 there, just to sort of be clear. So in the second case, what we have is 1 times 0.99, okay? And this is 1 times 0.99 by 0.9798, and so on. And what we do here is, like, this is the same number, just what we do here is we multiply it by 0.935. We just keep multiplying these cumulatively, these numbers here, okay? And that's how we come up with these calculations. So what we're going to do here, so we disregard this time period here. So we just sort of stick to the main time periods that we're going to use. 0 to 50, 50 to 100, 100 to 250, okay? Or 50 to 250, which would be this period here. 100 to 250. I'm getting tongue-tied. Yeah, essentially. Anyway, so that's the sort of take into account the censoring, and so on. So it's essentially just cumulatively multiply, consecutively and cumulatively multiply all these numbers here. Okay, to get these numbers here. Okay, so you can work that out with your calculator. So yeah, so just actually as a remark, I didn't really sort of hammer this point home, but the experiment goes on to 450 hours, okay? So that is the censoring there, okay? So this is how we just constructed here. So essentially what we're doing here is just like, this is our 50, 100, 250, 400, 450, and 500. Sorry, that's the that's with respect to the x-axis there. Okay, and essentially the heights of the step function are these numbers here. So, for example, this drops to 0.99 here, 0.97, and so on, until we get down to here, 0.5128. Alright, 0.51, 5219, 5291 even, okay. There, okay. So, that's it. Probability of survival at 300 hours. Essentially, it's a step function, okay. So, we're looking at this interval here, okay. And when we get that out, it is 0.9070, okay. It's consistent between 250 to 400, okay. Likewise, for 400, we're down here, 0.5291, okay. Sorry, just to be absolutely clear, I sort of, when I'm verbalizing it, I'm a little bit brief, but it's less than or equal to for the lower part of the interval, or the lower bound of the interval, and less than for the upper bound of the interval, okay. So just watch out for that, okay. 600 cannot be estimated without additional assumptions, as it lies outside the range of our values. That's what we sort of said earlier. All right, we'll leave it there.